Hey everyone, thank you for coming to this meetup. And thank you, Milosh and Alex, for hosting me. I am going to talk about what is in GraphQL today, and I will be talking about it from a misconceptions point of view. Before I get started, I want to introduce myself. My name is Shruti Kapoor, and I am in sunny California, USA, in San Francisco. You can find me on Twitter at Shruti Kapoor08 or on Twitch at Shruti Kapoor. And I host co-working live sessions where I invite people to bring their side projects so we can all work together, stay motivated. I work at PayPal as a senior software engineer, and I've been working with GraphQL for over 3 years now. When I first started with GraphQL, there was a lot of questions I had in my mind, and I could not find those answers anywhere. For example, is GraphQL similar to Graph, or what is the QL in GraphQL? And through this presentation, I want to help answer those questions for you guys if you have those questions, and I want to solve any misconceptions that you may have. If you're interested in more talks like this or more blog articles like this or about GraphQL or JavaScript in general, you can follow me on Twitter where I share out any blog posts and articles that I made. And if you've been following me on Twitter, you know that I aggressively tweet dev jokes. So of course we have to have dev jokes today as well. So I'm going to ask you a question and then you can answer it in the chat. I'll look at the chat here to see your answers as well. So first question, where do programmers hang out? Let me open the chat here. We don't. That is true. Well, we hang out at meetups, right? We're at Foo Bar. Okay, next one. How did HTML get drunk? It had too many BR. What did the developer say to the Git repository? Fuck you. Yeah, if you want to look at more dev jokes, read more dev jokes, you can find them on GitHub. There is a repository called github.com/shrutikapur08/dev joke. But anyways, let's get started. So today I'm going to talk about what is in GraphQL. And specifically, I will dive deep into what is GraphQL versus REST and give a brief introduction of how GraphQL and REST are different. We'll look at some misconceptions, 10 misconceptions. We'll talk about some good things from my personal experience. And if you are interested in GraphQL, how you can get started. So the first thing, let's talk a little bit about what is GraphQL versus REST and how it compares. So for the purpose of this presentation, I'm going to be going over this example. Let's say that we're building a library app and we want to show the title of the book and the author of the book. So we're only interested in two fields. The title could be a string. The title would be a string, and then the author could be an array of strings. So there could be one or more authors. And so that's the structure of the data that we're looking at. Let's say that we are building an app where we just want to show the title of the book and the author, one or two authors. If this is an app that we're building, there's usually 4 to 5 different steps in building an app. The first step is we need to think about what data we want to send to the server. So what data should we get back? What data are we supposed to send? So like, for example, IDs and things like that. In the REST world, we'll look at the API documentation and we'll find out which routes we need to call, which methods are available. So for example, if you may have found out that there is an endpoint called books, there's an endpoint called authors, and that endpoint can be useful to us. In GraphQL, instead, before looking at the documentation, we have to think about what data we need. So in this example, we're building a library app. We need the book and the author. So those are the two fields that we need. The next step is that now we know what data we need to send. Now we have to create a request. So in the REST world, we have our endpoint books and authors. We have to find out what does books and author accept. So they may be accepting an ID, they may be accepting a string or things like that. So you have to find out which parameters the endpoint accepts. In GraphQL, we have an endpoint / GraphQL, and that's the only endpoint we have. So we don't have like separate /book /author endpoint. We just have the one endpoint. And in order to get the data, we need to first create a query of fields that we need. So for example, here we'll need the title of the book. So we have a query of field called title, and then we need the name of the author. So we'll have author name. So now we know what data we need to send. The next step is to figure out in Rust which verb we are going to use. So we could have a get or a post or a patch, a delete or put. In GraphQL, there would be either a query or a mutation. So query is when we need to get the data. It's similar to REST get, and mutation is the job of post, patch, delete, and put. Okay, so now we know that we need, let's say, query. In Rust, we need get to fetch the data. We've got the IDs, we've got the fields that we need to send. The next step is on the server side, we need to make sure that we've got the methods that can handle that. So we've got retrieve authors that accepts an author ID, sends back the author. We've got retrieve books that accepts a book ID, sends back the book. Similarly, in the GraphQL case, on the server side, we need to make sure that we've got the resolver for the query that we are accepting. So for example, if we've got a field coming in, which is book or title, we need to make sure that we've got a resolver. So resolver is similar to the resource implementation in REST. It's basically just a function that helps you send back the data for the field that was requested. So if you've got title, that function may do something like fetch it from the database or call another endpoint or call another REST API in case it's an orchestration layer. So resolver does the magic of finding which data to send. So now at the server side, we built our server implementation. The next part is we have to send that data back. And on the client side, we need to parse that received data. So in REST world, we usually get a JSON object. We also get fields that may not be the ones that we're looking for. So if we ask for title, there may be other fields that we have not requested. Whereas in GraphQL, because you requested for the data, you only get back the data that you asked for, and which is a really powerful thing about GraphQL. So you also get back a JSON object, but you only get the data that you had asked for. Now let's look at some of the myths that people have had about GraphQL. Like any professional engineer, I did my research on Twitter and I asked people, tell me some misconceptions that you had with GraphQL. And the most common misconceptions are, I narrowed the list down to 10 misconceptions, and the most common misconceptions are here. The first misconception that most people have is that GraphQL is similar to Graph, or that GraphQL is similar to the SQL because of the code. Also, another misconception is that it only works with graph type data. And I think maybe because of the way we present GraphQL, it feels that GraphQL does the magic of fetching data automatically. Another thing I think that a lot of people have is that with GraphQL, you don't need to manage your data on the client side, or like you don't need Redux, and that REST and GraphQL can't coexist because GraphQL is very different from REST. And because it feels that GraphQL is so difficult to onboard, it feels a lot of people have the misconception that GraphQL is really difficult to introduce in an existing project. So let's look at some of these misconceptions in detail. Let's first talk about the one that's most commonly found, which is that GraphQL is similar to Graph. And the misconception here usually that people have is that it's somehow related to D3.js, or it's kind of similar to the Facebook's Graph. But actually, the graph in GraphQL works for data that looks or feels like a graph. So for example, here we have the book has a title, the title is a string. So this way we are drawing the connection between the data, we're drawing the graph between data, and that's what the graph in GraphQL represents. Another example is that you may have a book and you may have the book's author. Then the author has also written a bunch of other books. So you're looking at book, then you're fetching author, then you're also fetching another books list from that author. So this way you're kind of like drawing the relationship between the different fields. And that's what the graph in GraphQL represents. So the misconception may be that it only works for graph-like structures, but it actually works for any data that can be expressed in terms of nodes and how they connect. So here we looked at books and we had the title. A book may have, the title may be like name or email or bio, but we're only interested in name. So that's the field that we'll use to draw a relationship in. The next misconception is that GraphQL is similar to SQL. And I think that's probably because of the QL in GraphQL. And a lot of people have misconception that it's kind of like another query language for databases, and that we may have to do something like select star, something like that, like a query language. But actually, the query language of GraphQL kind of means that this is just a way for asking for data. So you don't write select star or whatever, but you just say it's kind of like a way of asking for the title pragmatic programmer. And the QL here represents asking the data from the API. So GraphQL is a query language for an API. It's not a database language. You can implement your database in whatever language you want. Your database may still be in a SQL type language, but GraphQL is just built on top of that to fetch data from the API, from the database. There are, however, libraries like dgraph that are all the way GraphQL at the database level as well, but it's not mandatory to have GraphQL at the database level. Another common misconception, like we talked, is that it works magically, that if you just pass a query and with the title book, with the field book or title, that the data would come back magically. But just like in REST, you also have to write, similarly in GraphQL, you also have to write the implementation on the server side. And for GraphQL, this is done in a resolver. So you'll write all the APIs that you need to call within that resolver. You'll write all the database queries that you need to do in that resolver. The resolver is kind of similar to the resource implementation in REST. And I think another very common misconception is that GraphQL replaces Redux. And I think this may be because GraphQL already reduces the need for having a state management library. A common misconception that people have said is that GraphQL replaces Redux, so why bother having something like Redux or even React hooks? But the thing is that GraphQL is just a way for asking for data. And once you have that data on the client side, you still need to manage it. GraphQL reduces the data that comes back to the client, so you may not need a heavy state management library like Redux, but depending on how much data you get back from the API, you still have to manage that data. And you can use whichever library you want. You may be able to just get away with React hooks, or you can use the default state management that comes from Apollo client, or you may have to use a heavier state management library like Redux, but you still have data that you need to manage on the client side. A very common misconception is that with GraphQL, you have to strip everything down. You can't have any REST microservices. You can't have REST with GraphQL. But actually, because GraphQL works really beautifully as an orchestration layer, one of the most powerful things of GraphQL is that you can have your existing architecture as is, and you can just build GraphQL on top of it. So you build GraphQL as an orchestration layer that in turn just talks to REST APIs. But for your client, they're just seeing one endpoint. So they're just seeing that the GraphQL endpoint. So you still get the benefits of having a GraphQL endpoint, whereas you can still keep your existing microservices architecture. That's a great thing about GraphQL. A lot of companies have also implemented GraphQL in parallel with REST. So they have the REST implementations for REST endpoints for whatever's existing, but everything that's new is going in GraphQL. So you can totally have GraphQL with REST or on top of REST. One library that does this kind of orchestration really well is OneGraph. And it's a really cool way of selecting multiple API endpoints. So they have examples of Spotify or GitHub, dev.to, and then you can kind of pick and choose whichever library, whichever endpoint you want, and then you can have that come up in your GraphQL endpoint. So you're not doing any sort of like integrations, but OneGraph does that kind of like magic stitching of data for you. So it's really cool. Check it out if you're interested in that kind of like orchestration. Another misconception that kind of follows from the same microservices architecture is that it's difficult to introduce in an existing project. And this was one misconception that we commonly had when we were starting to adopt GraphQL in PayPal, because a lot of people thought that it's kind of like an all or nothing and you need to replace everything that you have in your REST API in order to introduce GraphQL in your project, or that it's only meant for like greenfield projects, something that's completely new. But the thing with GraphQL is that because it works really well as an orchestration layer, you can kind of pick and choose whichever endpoint you want. So you can start with a small endpoint that doesn't have maybe a lot of audience, doesn't have a lot of stake, and you can kind of convert that into GraphQL, and you can slowly start migrating your app one endpoint at a time. Another really common misconception is that GraphQL is only for like JavaScript or only for front-end folks or only for libraries that use React. But the great beauty of GraphQL actually lies on the backend because you're able to only send the data back that the client needs. And that's amazing because on the backend, you can add fields to the existing API without having to deprecate, because there's only one endpoint, there's only the GraphQL endpoint. You can add fields without having to change the version, or you can intelligently look at which fields are being used so that you can either deprecate it if you need to, or add a deprecate flag, or see the instrumentation on that field. So you can see how many people are using a particular field. So I think the real beauty of GraphQL comes from the backend. Another common misconception is that GraphQL will write database queries itself, that you just need to take care of the query or the mutation, but everything behind this happens itself. The thing is, again, GraphQL is similar to how REST has a resource implementation. So you still need to do all the magic of doing your database queries in your resolvers, unless if you're using a library like Prisma or Neo4j that kind of does this for you. Another really common misconception is that you need to have a really big client like Apollo or something to have GraphQL in your project. The thing is that GraphQL is actually just a curl command. People think that in order to get GraphQL, you need to build a GraphQL server, it requires a third-party client. But because GraphQL is just like an HTTP request, it's just an HTTP API, you can just do a curl command, just like how you would do with the REST. For example, here we've got the curl command, and then the only thing you need to worry about is the data, because we have to fetch for the fields. We have to fetch for which field we need. So you can pass that fields in the data part, and you can fetch the exact field that you need, but then pass in your GraphQL endpoint as the endpoint. Sum up, the 10 myths that we looked at was GraphQL is similar to Graph or SQL. We looked at why GraphQL only, we looked at the misconception that GraphQL only works with graph type data, that data fetching works magically, or that GraphQL replaces Redux, REST and GraphQL can't coexist, and GraphQL is difficult to introduce in an existing project. GraphQL is only useful for front end and it will write database queries itself, or that it requires complicated clients. From my personal perspective, I really like GraphQL because I've been using it a lot on the front end and now a lot on the back end as well. And I think the best thing that it worked for us was that as a front end developer, GraphQL gives you type definition for free. So as a front end developer, I don't need to do the validation of the data. So for example, if I say that title is a string, and then if a client passes, let's say, a number for that field, GraphQL will automatically throw an error there. So as a front end developer, that reduces the validation that I need to do on client's data. And at PayPal, one of the great things about introducing GraphQL was that it brought our front end and back end teams together, because we have to establish a schema at the beginning of the project itself. We sat down together and we discussed all the fields that we need. And our schema was then driven by our UI instead of being driven by what data we need to send, like blindly sending that data back. So it increased the collaborations between our team, and it brought our teams together because we set up a contract in the beginning itself. And then that also helped us to independently work and intelligently work on our APIs, on our front end and back end bit independently. Another cool thing about GraphQL of introducing it on the back end was that it gave us powerful instrumentation of the data, and specifically to a field level. So the data is super granular, and that helped us understand which fields were being used, so that the fields that were not being used, we could intelligently deprecate them. An amazing thing about GraphQL is that because you're only getting back the fields that you asked for, it helps to reduce overfetching of data and underfetching of data. Overfetching of data means that you're getting too much fields, and underfetching means that you didn't get the field that you needed, so you have to make another request. And because with GraphQL, you can ask for everything that you need in one go. You don't have to do multiple routes. And an amazing thing about GraphQL, especially at PayPal, was that because there's one endpoint, we can keep pushing updates as often as we need to, and we don't have to worry about increasing the versions or changing versions or deprecating versions or like introducing breaking changes. So if you like GraphQL and you want to get started with GraphQL, here are some common places to get started. I think an amazing place is the GraphQL docs, official docs itself, which is on graphql.org. It has It has a list of FAQs as well, which is really amazing for a follow-up of this talk if you're interested. Apollo Docs, Apollo is actually one of the libraries that is used for implementing GraphQL on the front end, on the back end. Apollo has amazing docs as well. And then Prisma has a docs, which is like a quiz-based approach of learning GraphQL, which I found really helpful. It's on howtographql.com. When we were introducing GraphQL to our teams at PayPal, the first thing we would show them is graphical tool, which is this tool here. And this is kind of like an interactive way of fetch data. And this was really helpful in kind of showing the power of GraphQL and the dev tools around it. So if you're interested in checking out GraphQL or graphical, you can find it here on GitHub. There's also lots of great tutorials as well. Egghead has a lot of good GraphQL resources. There's an amazing book by Eve Parcello and Alex Banks on learning GraphQL, which is a very good introduction of GraphQL. There's also courses on Udemy. The specific one that I really like is by Stephen Grider. It's called GraphQL with React, and it was very helpful for me to introduce GraphQL in my current architecture at PayPal. If you're interested in getting started with GraphQL, I've also written a blog post that you can find on my GitHub on github.com/shrutikapur08/blogs. And it's an introduction of what is GraphQL and how it differs from REST, things like that. So to sum up, today we talked about four things. We talked about what is GraphQL versus REST, the misconceptions, some cool things that we liked of GraphQL at PayPal, and how you can get started. Before I end the presentation, I also want to share something that I'm doing today. Some of you may be aware of the crisis that's going on in India related to COVID. The country is breaking down, the system is breaking down. So I am doing a fundraiser today at 9 p.m. to 11 p.m. PST, which may be tomorrow for you guys, on my twitch.tv/Shruti Kapoor. And basically, I invite you all to donate whatever little you can to a foundation for helping COVID relief in India. But also, in addition to everything that you'll donate, I'll also donate $1 per viewer. So I encourage you to join. You're helping out just by being there. And I want to end the presentation with one final dev joke. Thank you, everybody. You've been an amazing audience.